The challenge: the human brain is the most complex structure in the known universe. But for decades, our tools to study it have been too primitive. Traditional brain implants are made of rigid silicon or metal. Because our brains are soft like jelly, these hard implants cause scarring and eventually stop working. Visual cue: macro shot of a human brain or neural network animation. The breakthrough: in 2026, researchers at the Technical University of Denmark, known as DTU, unveiled a solution. Introducing the mAxialtrode. This needle-thin, flexible implant is as soft as the brain itself. Developed by scientist Kunyang Suai and Professor Christos Markos, it represents a 3-in-1 breakthrough in neurotechnology. Visual cue: laboratory setting, scientists working with fiber optics. How it works: the 3-in-1 tech. The mAxialtrode is a microfluidic axialtrode. It can perform 3 vital tasks simultaneously. First, it records electrical signals to listen to neurons. Second, it uses optogenetics to speak to brain circuits with pulses of light. And third, it has integrated microfluidic channels to deliver precise medication directly to targeted areas. Multi-layer precision: most implants only record from the tip. But the mAxialtrode has sensors along its entire length. This allows it to monitor multiple layers of the brain simultaneously, from the surface cortex to the deep regions of the hippocampus. This layer crossing ability is essential for understanding how the brain processes complex thoughts. Brain: the scientific foundation. This technology is backed by a landmark study published in the journal Advanced Science in January 2026. Titled Multimodal Layer Crossing Interrogation of Brain Circuits, the paper details how these fibers are manufactured. They are heated and drawn out like sugar threads, creating a device that moves with the brain rather than against it. Visual cue: scientific journal cover or text graphic of the study title. Real-world applications: the medical potential is massive. For Parkinson's disease, medication is started the moment a tremor is detected. For chronic depression, it can stimulate reward centers with light. And for epilepsy, it could quench a seizure before it even begins. Because it is flexible, it can remain safely implanted for years, acting as a pacemaker for the mind. Visual cue: healthcare professional talking to a patient or a 3D animation of a brain being reset. The future of neurology: we are entering the transistor moment of neuroscience. By bridging the gap between machines and biology, the mAxialtrode is helping us decode the language of the soul. As we refine this technology throughout 2026, the dream of fixing the brain's wiring without surgery is becoming a reality. Visual cue: futuristic digital brain or a sunrise over a modern city.